thank you for coming. So today I'll talk about my personal experience. Yeah, this is our manager, so if you want to say a few words, or...
Sorry. Yes.
Microphone is there.
Sorry. Just in the other room, as you saw. So, thank you very much for coming here.
My pleasure.
Yes. Remember that we will have the question at the end of the talk. Okay. Please be aware of that. I'll give you a sign for the time.
Sounds good.
And so, without further ado, I'd like to welcome Arthur with a big applause. Thank you, management. And I'll let you the stage. Thank you.
Yeah, thank you. So I guess you're here because, well, you kind of deal with data visualization, maybe daily, maybe not daily, maybe you build some projects. So I'll try to make it as interactive as possible, and I hope you will learn something how to set up your data visualization project and how to avoid some common pitfalls. Because for me, I'm very easy to inspire person, and usually when people come to me and well, start talking about visualization, I'm all in. But unfortunately, well, the real life is a bit hard. And I thought that data visualization project is easy, but, well, it's not. And if I look back into my path into this data visualization project, it's not absolutely streamlined. So it has some pitfalls. And I learned a lot along my way. So, and today I'm here to share some my experience so that you can avoid maybe the same mistakes in your personal project. So by the end of the talk, you'll have some toolkit that you can use in, well, to avoid those things. And if I retrospect back into my journey, so I kind of know where I was very bad. So I didn't know how to make the informative figures. So when we talk about visualization, everyone here in the room maybe has its own imagination what visualization is. Well, yeah, I learned hard way how to build the nice figures. I also found myself like in a loop, like here. So when I try to prettify things without creating any value, I spend just time, but yeah, with no much output. I also, yeah, I didn't know how to version properly the code and how to interact with data visualization code. So I know how to use the Git for the software engineer, like software projects, but for the code it was a bit challenging because I used the Jupyter notebooks and I was completely lost. And another thing is about the visualizations. I thought that they're unbreakable, so I wrote a method and I kind of leave it in the Git source file in the Git. And yeah, in a while I discovered, okay, it's not working anymore because the data changed a bit. It cannot fit into my memory of the laptop. I also made some mistakes and discovered too late, so that's how I learned that the notifications on your data pipelines are very important. So you have to be sure that your code is still functioning. And yeah, basically, I had to reprocess the data. And before I was a big fan of the Jupyter, but in reality now I don't use Jupyter a lot. So and you'll see the structure of my project, how I avoid using that, and you will see why I'm doing that. So that's the things that I kind of struggled with in the beginning of my journey. And yeah, and today I'll talk about the, well, it's kind of philosophy. It's the things that you should keep in mind when you create a data visualization project. And the first thing that I really advise you to do is to think about your audience. It's because, well, as I said, like everyone here in the room has its own definition of data visualization. And usually people don't over-communicate. And, well, in some cases, some people, when we talk about visualization, mean something dynamic. It's kind of a dashboard. It can be Grafana or Tableau, or it can be a static report. Or they even don't need any visualization. They're just too busy to get any visualization. They need a number to predict what will happen in the future. And that's why, well, the first thing I draw here on the slide is what I usually do when I need to set up the project. So I try to get a piece of paper and communicate with my stakeholders whether or not this visualization will work. It also helps me in a few different ways because sometimes well, yeah, we all love software. It's easy to go and jump and to implement things straight away, but it's way easier if you have a plan what you need to visualize. And sometimes, like drawing something on the paper, it can greatly help, especially if you keep an idea in your head that, okay, take some extreme cases. For example, you wrote awesome algorithm that performs like 1,000 times better than all other algorithms in the field. But yeah, you need to think in that extreme case, how will you present the data so that, well, it's consumable. It's not like, yeah, and it translates the right message for your audience. In my presentation, I kind of stick to the Matplotlib because, well, I found it like foundational for all Python other visualization packages, but it's not related to Matplotlib. And in reality, I mean, the best visualization framework is the one that you know the most and you're the most comfortable with. So I just use Matplotlib, and yeah, because it teaches few object-oriented approach for visualization, and in general, yeah, can translate well to other frameworks that you could use. But enough pictures, so let's jump into the code. So when you set up the project, so this is a high-level overview of the things that I usually set up. So I have my project, which is 2023 PyCon Italia. And outside of that thing, I also have the .github folder. It's basically because I decided to use GitHub continuous integration in this specific case. And this workflow is very important, and I hope you to convince why. And for example, having this folder and having that YAML file allows me to create something like this in my data visualization project. So what I like about that approach is that at any commit that I made to my GitHub repository, I have what is called gallery.pdf file that basically visualizes all the plot functions that I wrote in my code. So if I introduce something new, or if I change something, I'm still sure that the artifact would be generated. I can take a look into my artifact, and I can see that all my pieces of code executed, and they still produce a figure. So that's how I ensure that, okay, my code is in a healthy state and nothing broke. If something broken along the way, the pipeline will fail, and it will notify you immediately, okay, your recent change broke not your current figure, but it broke some figure that you introduced somewhere in the past, and it's better to go now, since you have the context, than to fix it. Now we know a bit. First we know the message, what we want to communicate. We draw it in a paper. We know how we can set it up on the high level. Now we need to understand how to communicate efficiently. And for that, the real game changer for me was the scientific visualization with Matplotlib and Python by Rougier. This book changed how I looked into the data visualization, and basically there is a chapter, it's like 10 pages, where he describes 10 design principles that you can follow in your workflow. And basically, if we name a few, you already know. So you need to know your audience, you need to identify the message that you want to convey people. You also need to adapt the figure to support the medium, which means that, yeah, it should be understandable, but by the people you're targeting with. The figure should be self-explainable. So if you look into it without any context or without any supporting text, so it should give you some idea of what's going on. You can use colors effectively, and you should not mislead the reader. The chart junk is usually some simplifications, like, or not simplifications, like the constructions that, you know, in a Word style in 2003, when you can build the shadows and all that stuff. So this is what is called the chart junk usually, because they don't bring any value. Message trumps the beauty, so it should be very informative. And yeah, as I said, get the right tool, and maybe it's not a Matplotlib in your case, maybe it's something else. But that's a theory, and how it works in practice is something like that. So sometimes I see in my experience the graphs like that. Maybe you think that there is nothing special here, but the thing that I always keep in my mind is the phrase that is on the top of the graph. The less is more. And basically, this is a video that I need to start somehow. Wait a sec. Is it working? Yeah. So you see the sequence of steps that we are taking. And if initially I had no idea what's going on in the graph, after, well, getting a few steps ahead, I can already start to tell you a story about this graph because, well, most probably I want to tell you the story about the bacon, and maybe I want to compare the bacon with other products. And you see how from the normal kind of graph before, you start to tell the message by utilizing those principles that we saw before. And yeah, that's what I mean by knowing and transferring the message, because the message on the graph before, it's way cleaner than on this slide. When I start any project, you saw in the list that don't trust the defaults, and that's actually very good advice. And this is the standard Matplotlib figure, but with some customization. It doesn't look like a standard Matplotlib figure, right? Because the title is moved left, so the labels are rotated, there is annotations, there are labels like the lines are labeled directly on the graph. There is also the node section. So that's usually very nice exercise for any framework that you start to use because, well, it allows you to become very fluent. So if you would know how to annotate your figure, how to label it correctly, you would be way more effective in your day-to-day work. And the nice thing about Python, it's like, because, yeah, everything in Python is an object. Matplotlib here is not unique, and any other library is not unique. So if you create a figure with Matplotlib, the figure is an object. It's basically canvas. And the axis where you draw your lines is also an object. So it means that you can go and you can change any attribute like after. So you can use the setter or builder pattern in your workflow and use it effectively. And if you look back into the code, so that's how this plot built. So there are a few things. So you see that I got those two objects, figure and axis, and then I just modify the axis object by setting some parameters, etc. So if you simplify it, it's in reality, it's few lines of code and you have quite pretty graph. Okay, you might wonder, you don't really plot in your day-to-day job, but I'm sure that all of us do some statistical analysis or something else. And graphs are very important into verifying the data. And that's where the next slide comes to play, because when we create the data, it's a nice idea to actually plot it. And I found this article recently, and I don't know, Stephanie is not here, but she's giving the talk tomorrow or tutorial on Matplotlib. This is original article written by Autodesk, but what Stephanie did, Stephanie is not here, right? No. So Stephanie wrote a package which is called Datamorph, and basically what Datamorph does, so it creates the data sets with the same statistics. Imagine if I create a, predictive model, and my model predict the dinosaur, so maybe it's not the right model. And what I mean by different data sets and the same statistics is something like that. So you see that the data set is changing all the time, but all the statistics keep the same. So that's why if you have any prediction model or whatever, it's very nice to visualize your data set and to see that it's actually maybe something wrong with my data pipeline here. So, that's it. So we can go now a bit deeper into the things that I usually keep in my project, and you'll have a GitHub repo after to take a look into the depth into that. So you can see that this is a more detailed structure of this specific project for this specific presentation. So you can notice two things at the moment. So there is a data folder, and then there is the src folder. And in the src folder, there are two types of functions. The one type is that starts with plot underscore and some other functions. So basically, that gives you maybe an idea that it's very nice to separate your data from your visualization code. And later you'll see why I think this is important, because before I was doing something like that, so I had the notebooks that is usually untitled, and then you put the versions, and then you spend half a day trying to find, oh my God, where I introduce some change, or if I need to reproduce. It was so painful to version control it, and you spend more time finding the right notebook to run rather than, you create some value. And that's why it's nice to chop this untitled notebook into two things, like in data and data visualization. If you even can chop the IPython notebook and write a Python module, it's even better. And why it's even better? Because it allows you to create lots of figures, and it gives you lots of flexibility. For example, in this specific case, I have a function to visualize the lines. And what I want to see the different colors, like color schemes, how they will look like if I apply to my, in the keywords if I provide it. And I can immediately construct that graph, and I can immediately compare, and probably, my favorite one would be this one, because it looks pretty. And if you look into the code, you see how easy to do. So you basically create a function that takes some keywords, and then you pass the different color schemes. It also allows you to, to interact with the reader, and this is a real data about the global warming starting from 1980 till the recent day. So you can see how you can misuse the data to convey different messages. Because if I would say something about the global heating is exponential, I would use something like this. Or if I would use, if I would convey people that, okay, global warming is nothing, so I would use something like that. And basically, having that pattern, you can easily change your graph, and you can easily see, are you biasing people? And basically, it's very nice to interact with that kind of code. It's also very nice because if you notice, it's like a separate Python function that also self-runnable that you can just call, and it will generate that plot and itself in the results directory. So don't trust the defaults and don't mislead the reader. And that approach is also very nice in versioning your code. Another thing that I found very useful, so I put only one test here, but tests are nice, and this also applies for the data visualization project. And what I mean by that, well, in my practice, I had the pandas data frame that I wanted to visualize, and basically the pandas data frame had a few columns, the column X and the column Y, and the way, few columns with Y. And what I did, I wrote a function to visualize the Y values. And then, okay, you push it, you forget it, you don't have any CI, the colleague comes, it modifies the processing code that now you have more than one Y column, and instead of having only 2 lines on your plot, you ended up in a mess of, in a black area on your scatter plot. So that you need to go and you need to remember what you did in your project. So it takes time to recover. So basically, remember, everything in Python is an object. You can write a test that, okay, if I'm satisfied with my plotting function, if it generates, I don't know, if all the values, if your plot design are less than 1, that my function generates the figure with 2 lines, etc. So you can get all that information from the figure object. And after, it's very easy to iterate. So I'm a user of PyCharm or VS Code. So you can introduce your visualization and save it into graphics form. And for example, in VS Code, you can use the plugin, which is a git lens. You can easily use the arrows just to go back into this vector format, and you can see rendered image on the right. So it's easier for data visualization to go and to iterate to see the graph itself, how it changed over the time. And then you already know the commit if you need to revert or reapply changes, or maybe go back and introduce something new. So that's a very nice feature. Coming back to the CI part of the talk. So for this specific case, I used the GitHub Actions. And I really encourage you to introduce CI for your pipelines. So it's as easy as writing a YAML. And there are some rules of writing that YAML, but what I like is that it reads nicely from top to bottom. So for example, in my specific case, remember I said that I like that in every my push to the repository, all my plotting functions, they are actually executed. So I'm sure that they are in functional state. And here, you can see that, I use Conda as my Python environment. I set up the environment, I run the test, and I call the assembled_plots.py that I'll show you in a bit. And as a nice feature, you have this CI in your pull request. So if you are not working alone on the project, so you can be safe that someone else doesn't break something in your code base. And that's how it looks like in GitHub CI. And that's actually the function that was maybe the most trickiest one that I had in my 8 years experience. But it looks a bit complex, but in reality what it does, it iterates over the functions in src folder and gets every function that starts with plot underscore. It exports all the functions from any Python file with plot underscore that starts with plot underscore. it executes it because by convention, I decided that my plot underscore function, it returns a figure. And then this figure is saved to PDF. And it's basically a loop to append all the PDFs into the file. So, and by the end, you have this gallery PDF file with all your visualizations. And that's how it's set up. So you might wonder, OK, I don't use the visualization and CI at all. So I also, how would I say, in my experience, I had some time working with the dashboards. I hate that because you have to do lots of clicking. But the one advice I can give you who use like a Grafana or Tableau is that, yeah, what I found in my practice very useful is to create two types of the dashboard. The one that consumed, like the customer consumed, which is a prod dashboard, and another one is staging. So, and basically it's coming back to my very first point, knowing your audience, you can go and ask, hey, I want to change the rocket into animal. Is it something you want? And usually people will give you feedback, and then it's easier to replicate dashboard than going into the prod dashboard and rolling something back. Because in my personal experience, when I try to keep only one dashboard, well, sometimes you change something in the settings, and well, the recovery is harder than actually, just copying something from staging to prod. And coming back, it's very nice to know the limits of your visualization code. And remember, I started my talk and mentioned one example of not knowing the limits. And what I mean by that is that, well, unfortunately, we deal with a Python. And Python, like many libraries, they try to load things into memory. And sometimes when you work, you want to speed up things. You don't use the real data sets. So you do use smaller data sets. You create your function. OK, you're fine. But then you start, you forget about that. And in a month, you start noticing that, OK, it's not working anymore. Why? Because, well, it's either the memory problem or it's like it's not visualized the long sequence of data nicely. So you need to change something in algorithm. So that's why knowing the limits, write your tests, multiply your input data by the factor of 100 or 1,000, and know that, OK, in that scale, I'm covered. So in the future 5 years, it still works. And basically, if I conclude, so we'll work collaboratively. So the aim for reproducibility, version control is very easier if you structure the code as I showed you with the Python modules and with the functions that you can reuse in your code. Setup monitoring, well, that's actually a very interesting thing that I think we should give it another talk, because for me it was not tricky, but if I would summarize it, usually I create a bot and then I have a daily report that sends me data. For example, in the real setup, you have a bunch of cron jobs that run daily, nightly, whatever. And each of them, they send some message to some dedicated channel with green or red. And for example, I just go to that channel and I see that if everything is green, everything is good. So monitoring is important, but if you don't, just set up CI. CI would be kind of your monitoring. And and after having the continuous integration pipeline, you can even set up the continuous delivery pipeline. So for example, if you have a business customer that want to have a report every Monday, in GitHub Actions, you can schedule the regular jobs. So it would be send it directly to them without you even in the loop. So. And that's how you can automate out yourself from visualization project. And if you're interested, it's a fully working project that you can find at the GitHub. This is, it's easy to find because you can just search by my family name, and then it would be the talks repository, and that part you can ignore, so you'll see it. And we are 25 minutes into the talk. And
perfect.
Yeah.
Perfect. Artem, you're amazing. Thank you so much for sharing the journey. A lot of great insights on data visualization, especially from testing to workflow. Very, very interesting. Thank you for sharing.
Well, if you want to know more, here you can see it in action, so it's working.
You're looking for contributors also to
No,
this
I don't.
project?
Well, I mean, I want to share because, how do I say, it was, maybe the things that I said, they look trivial, but it took me lots of unsleepy nights, I would say, to learn those things, and I don't do them anymore. So I would spend some time setting up the CI pipeline.
Thank you very much. There was an interesting question on, sometimes as data scientists, data visualization,
Right.
we analyze some parts of the chart itself, and that is a part of the interpretation of the data scientist
Right.
itself. Do you find any risk in getting too much the interpretation from the users due to highlighting some particular part of the chart?
Well,
do you think is yeah?
Yeah, I mean, it comes back to to the topic of communication, I think, because usually what I found in my practice nice, it's not working alone on the project, because when I work alone, you saw that loop in my one of the slides. That's where I am. So I can spend a day trying to prettify things and do some cool stuff that I think is cool, but in reality it's not cool. And that's coming back to your question is yeah, communication is important, and it also helps you to, what I usually do, I create a chart yeah, as I said, put a title, put everything, come to people and just ask, what do you think about that? So, and then you start learn that, okay, what you was working, it doesn't transfer any message. So you need to think how you maybe need to use the color effectively or something else. So, and I don't know if I answered the question, but basically if you structure your code in a way that it's easier to manipulate, then you're faster in terms of showing and changing your graphs or whatever you create.
Yeah, thank you very much. And on the output, to have another person review the interpretation where you put your attention on is very interesting.
Yeah.
In order to not be biased in seed interpretation.
Yeah.
There was also a funny question before on if there is any practices on when someone of your team or your company use too much pie chart. If there is any way to approach it and say...
there is a simple way. The book I cited, it basically says, don't use pie charts at all. So, and if you need some reference, you can go back into this Rogier, because he is actual scientist. I mean, he is less known than other people, but I really love his book. So you can direct him to him and say, okay, based on his opinion, you never should use it. So.
Thank you. One last question. Someone asked, you explained very well that behind any graph product is like a product in Python, can be manipulated. Right. What about sharing this the data visualization and graph projects? Do you have any advice for that?
That's actually the next steps that you can take, and maybe that's where CI is also very helpful, because what you can do, you can abstract your code then into the package that other people can use. So you can use, if you work inside the company, so probably you have your own index, so you can package your code in a package that would be accessible by everyone, and then you can just do PyPI, redirect to the registry, download the package, and reuse the function. So that's, I found it useful. So in the code, I used similar structure at my work. So yeah, and it's shareable as a package, and other people, they can pip install and use the same visualization functions. Yeah, they know that they are tested, that they are good. If they want to contribute, they contribute.
Thank you very much. I think that's answer for the question. So big applause to Artem again.
Thank you.
Thank you.